Another thing that we see an awful lot of in the news these days in a variety of areas are drones. You see we've got a drone back here with a mock-up of our IB Flex receiver plus the directional antenna. Drones allow you to cover a lot of area in a short period of time. Drones can get through very dense urban environments doing measurements, and our high-speed IB Flex scanning receivers can tolerate the faster motion that drones will provide in doing the scanning. We've used drones, as you can see in the picture here, to address stadiums and large event venues where you have to fly multiple circuits around the venue to do measurements at different tiers of the stadium. Small cell environments are a good place for using drones because you have a number of small cells close together and you want to measure a circuit around those cells on a very rapid economical basis. And finally, drones are useful for measuring macro cell radiation patterns. Normally with scanning receivers on the ground, you get the down beam, you get the main beam there. As you push beams down, there's typically an upper side lobe that comes out of the beams. And if you push the beams down, those beams can actually interfere with adjacent towers. And the drones are the only way you can actually see that type of interference and measure it that's not visible on the ground. So drones are becoming more and more a part of our daily life and more a part of the solution set that we have in terms of doing wireless test and measurement. You know, the Internet of Things is everywhere. If you look, I think the research says we expect 5 billion connected devices by 2025. I think we're probably close to 5 billion connected devices today. I think some of our counterparts from Microsemi was talking about 7 billion connected devices at this point. So the Internet of Things is on us, and we need to support connectivity to all these Internet of Things. And so there are a number of solutions being pushed by the standards bodies. Narrowband IoT is probably the solution that's being pressed most by the International Telecommunication Union and 3GPP. Narrowband IoT comes in a number of different flavors. There's in-band inside the LTE band that can be accommodated typically with software updates from the radio manufacturers. There's guard band LTE, narrowband IoT that sits between the LTE carriers and makes use of unused spectrum, but runs the risk of being in the guard band. And then finally, there's standalone IoT that will run in the 200 kilohertz GSM carriers. There's all these options available. We're starting to see deployments in the in-band type of narrowband IoT at this point. And you know, narrowband IoT and IoT solutions are typically characterized by low bit rates, less than a megabit, tolerating latencies in the order of seconds, if not longer. And so it really fits well with kind of the best effort exercise you see with the internet. So we see scanning receivers being important here because these are typically very low level signals trying to be received by very inexpensive devices that are $1 or maybe $2 or €1. And so the devices typically have very poor performance, and you need a robust network to be able to connect to them and maintain connectivity. So pre-deployment, we use our scanning receivers to look for empty slots in the LTE frames to ensure that there are slots for the narrowband IoT that the configurations will support it. Post-deployment, we can look at the coverage and the availability of the signal in environments that typically you wouldn't find users in. So it's in meters, in basements and underneath houses, on the sides of buildings and so forth. And then finally, we do layer 3 decoding on the narrowband IoT signals to validate that we're connected to the right base station and the right network. So narrowband IoT, the Internet of Things, is a very large thing coming down the line here, and it'll be evolving for a number of years. Of course, the big buzz these days is all about 5G. 5G as we see it today in the millimeter wave, in the upper gigahertz, 29, 39, 40 gigahertz, is really a line of sight type of application. It's hundreds of meters, it's probably the range of it, but it's characterized by very low latency, very high bandwidth, and very directional type of solutions. Beamforming is a very important part of 5G technology. These things work very well in a fixed wireless environment, but mobility is going to be a challenge for 5G, and we're going to have to work very hard over the next few years to evolve that, and scanning receivers are going to be an important part of that. You can see I've got the 5G roadmap here for mobile broadband. They're not really going to get the standards finished until 2018, 2019. And even if you have the standards, the frequencies really aren't well suited for mobile use just because the ranges are hundreds of meters and not kilometers. And so the 4G networks are still going to be important. You're going to see an approach they call non-standalone, where the 5G carriers are going to be bound to 4G networks and the signaling to associate the calls. And you'll see the 5G for doing bursty type of data solutions to it. So today we are building prototype scanning receivers to support the millimeter wave solutions, primarily doing power measurements to validate patent model tuning, link verification, and path loss. And then we'll move on to decoding and beam tracking as we start to become a little bit more intelligent in the deployment of the products. You know, there's still a lot of uncertainty. The bands to be used are still variable. I think the ITU has 11 different bands in the millimeter wave that they're researching. All the different jurisdictions have different frequencies available. So there's still a lot of uncertainty and a lot of trials going on. Obviously, the Olympics here in 2020 is going to be an important milestone, and we'll see a lot of work that takes place in that area. So there's a lot going on test and measurement in 5G. We believe scanning receivers are an important part of that solution. They're a very flexible tool, independent of the network. We believe we have a very strong technology offering, and we have a very strong partnership with Marabun here in terms of supporting the customers in the market. And we believe that 5G, IoT, interference hunting, and the Internet of Things are all going to be very important as we move into the coming years here. And wireless is going to continue to become more complex and need more tools like our scanning receivers to solve the problems. So that's my talk here today. Thank you very much for your attention. Any questions, I'd be more than happy to address those questions after outside the event here. Thank you.